Hello students and learners. So we shall be discussing about IC processing, which is the last topic in our unit 5 according to RTO syllabus of IC technology. I am Neha Sharma, assistant professor at Department of Electronics and Communication Engineering at Engineering College Jhalawad, Rajasthan. So in IC fabrication, first of all, let's see what are IC or integrated circuits. So this definition I have taken from just Wikipedia, you can get it. An integrated circuit or monolithic integrated circuit, also referred to as IC or a chip or a microchip, is a set of electronic circuits on one small flat piece called chip or semiconductor material, that is normally a silicon. The integration of large number of tiny MOS transistors into a small chip results in circuit that are orders of magnitude smaller, faster and less expensive than those constructed of discrete electronic components. In other means, integrated circuit is combining all the active and your passive devices which are in the order of micrometer and nanometer regime into one chip or into a one wafer, I can say. This is known as your integrated circuits. The number of the circuits is around between millions and billions. So accordingly, we have this integrated circuit. So we have discussed in the previous lectures about these step flows. Silicon processing includes the manufacturing or the making of your wafer from the raw silicon, and moving on to the masking. Then we perform the photolithography process, which is basically the patterning, and then deposition, then diffusion and ion implantation, then your metallization and planarization. So photolithography, after photolithography we will go to etching, and etching process can come after your diffusion also, after deposition also. You have this photolithography, and a photolithography combined with etching process can be done in various steps in between, that we will see in our subsequent NMOS, PMOS and CMOS fabrication when we go through that process. So these are some of the steps. The ranking of the steps can vary a little bit. कि फोटोलिथोग्राफी के बाद डिपोजिशन के बाद हमने डिफ्यूजन किया, फॉलोड बाय फोटोलिथोग्राफी एंड एचिंग प्रोसेस. देन एचिंग और फोटोलिथोग्राफी तो हर प्रोसेस के बाद होना ज़रूरी है टू गेट अ फिक्स्ड पैटर्न. एंड एट लास्ट मेटलाइजेशन बाय एल्यूमिनियम, कॉपर और silver or gold by that, and then last one is your planarization to get a very flat surface. And then last one I will include as your packaging, and then it will go for testing and other things. So this is your typical fabrication process flow. So now we will discuss about your NMOS fabrication. So process 1, the process starts with oxidation of your silicon substrate, as you can see in your diagram B, in which a relatively thick silicon dioxide layer, or called the filled oxide, is created on the surface. Then the filled oxide is selectively etched to expose the silicon surface on which the MOS transistor will be created. You can see here this portion, this part is etched. So here in this part we will grow your MOS transistor will be created here. Then after that thin oxide layer is deposited. This thin oxide layer is actually work as your oxide for your gate. गेट जब बनाना होगा उसको हम गेट ऑक्साइड भी बोल सकते हैं, तो उसके लिए ऑक्साइड लेयर की ज़रूरत पड़ेगी. सो व्हाट टिपिकली योर गेट कंसिस्ट्स ऑफ, तो टिपिकली आपका एनमॉस ट्रांजिस्टर कुछ इस तरह से होगा. यहाँ पे आपका SiO2 लेयर है, एंड देन ऑन दैट वी हैव पॉलीसिलिकन. तो ये जो SiO2 का लेयर जो हमें ग्रो करना है, इट इज़ दिस थिन ऑक्साइड. So on the top of it, of course, we need a polysilicon. So in the step E, we will use on the top of the thin oxide layer, a layer of polysilicon or polycrystalline silicon is deposited. So basically polysilicon is used both as your gate electrode material for your MOS transistor and also as an interconnect medium in silicon integrated circuits. So your undoped polysilicon has a relatively very high resistivity. So it can be reduced by further doping it with your impurity atoms. So at last, so in step number F, your polysilicon is patterned uh, to form your gate structure, and at last your gate structures can be formed in your G diagram. And here the etching has been done for etching of your thin oxide layer for the interconnects. So after deposition, the polysilicon layer is patterned and etched to form the interconnects and the MOS transistor gate. So as you can see here, ये गेट स्ट्रक्चर कंप्लीट हो गया है हमारे यहाँ पे, एंड इंटरकनेक्ट्स बनाने के लिए ये स्पेस छोड़ा गया है. मूविंग ऑन टू द नेक्स्ट स्टेप्स इन एच, सोर्स एंड ड्रेन रीजन हम लोग बना रहे हैं यहाँ पे. इसके लिए वी आर यूजिंग आयन इम्प्लांटेशन टेक्निक, आयन इम्प्लांटेशन और डिफ्यूजन. बट जब भी सोर्स और ड्रेन रीजन बनाने पड़ते हैं विच इज़ शैलो, तो वी विल गो फॉर आयन इम्प्लांटेशन प्रोसेस. So your the thin gate oxide is not covered by polysilicon. So it is also etched away, which is expose the bare silicon surface on which the source and drain regions are to be formed. And the entire silicon surface is then doped with very high concentration of impurities, either through diffusion or your ion implantation process, as I have told you. So अगर हम लोग NMOS बना रहे हैं तो डोपिंग ऑफ कोर्स N से ही उसकी N टाइप की ही डोपिंग करेंगे हम लोग, डोनर एटम्स की बेसिकली. And then in step number I, very insulating oxide layer is deposited. So you can see in the previous step that the doping penetrates the exposed areas on the silicon surface, so it can ultimately creates your source and drain region. And this process means wherever we want to, wherever we want to grow your source and drain region, it will come below your polysilicon layer, which actually makes your which basically makes your channel part. तो वो ऑलरेडी प्रोटेक्टेड है बाय द योर पॉलीसिलिकन लेयर, तो उसके नीचे ही सोर्स एंड ड्रेन रीजन्स फॉर्म होगा. सो दिस प्रोसेस इज नोन एज योर सेल्फ अलाइनमेंट प्रोसेस. Okay, so once the source and drain regions are completed, the entire surface is then covered with an insulating layer of your silicon dioxide. Silicon dioxide और insulating layer जो हमने लगाई है इन स्टेप नंबर, insulating layer की हम लोग ने कोटिंग कर दी है. Then again it is patterned. So the insulating layer is then patterned in order to provide contact windows for your source and drain regions. तो यहाँ से contact windows we are getting for your source and drain region. Okay, then after this process we will go for your metallization. So the surface is covered with evaporated aluminum, which will form the interconnects, as you can see here. And finally the metal layer is patterned and etched and completing the interconnection of your MOS transistors, as you can see in your last step. And usually a second layer of metallic interconnects can also be added on the top of this structure by creating another insulating oxide layer, and these can be connected by your cuts or vias, and then this patterning and deposition process can again be achieved. So if you want to go for two layer of metallization, then such steps are required. So you can see here, so planarization steps is of course after this thing, to get a very flat surface after this metal contact, we will go for planarization technique, and finally our NMOS is fabricated. So so following all these steps, we can go, means these are basic steps for your for fabrication of your NMOS, and in the coming lecture we shall be discussing the fabrication steps for your PMOS and for your CMOS technology. Thanks for today.